Welcome to Section 6.2, Solving Systems Using Substitution, Day 2. As a warm-up, I want you to solve the system using substitution and check your answer. Let's see how you did. Again, noticing that the first equation has x all by itself, we put the 4y in for x in the second equation. So we have 3 times 4y minus y equals 77, 12y minus y equals 77, 11y equals 77 after combining like terms. Divide both sides by 11 to get y equals 7. Over here, we're going to we're going to solve for x. So we use the first equation. So we have 4 times y, 7, equals x. So x equals 28. Then we check, is 3 times 28 minus 7 equal to 77? 84 minus 7 does equal 77, so it checks. Again, let's review the steps for solving a system using substitution. Step 1 is to solve an equation for one variable. Now yesterday, in our first section, or first part of the section, we did equations that had the variable already solved for. Today, we're going to have to do step 1. Step 2, remember, is to do the substitution. That's when you put the equation that you solved for in step 1 into the other equation. Step 3 is when you solve the equation. That is when you get the variable all by itself. Step 4 is when you plug back in to find the other variable. So you substitute your answer that you got from step 3 into the equation. And finally, your last step is to check your solution. And that's where you substitute both answers into the equations to make sure you have a correct answer. So let's review how to get the variables by themselves. So let's solve this first equation for y. We have 5z plus y equals 8. First thing we want to do is subtract 5z from both sides to get y equals negative 5z plus 8. In this one, we have 3x minus 3y equals negative 9, and I want you to solve for x. Step 1, add 3y to both sides. Step 2, you have 3x equals 3y minus 9. Divide everything by 3, so 3x divided by 3, 3y divided by 3, and 9 divided by 3, to get x equals y minus 3. We'll need to use that in order to get our equations ready to use substitution. Now what I like to look for when I do substitution is I like to look for an equation that's going to be easy to get a letter by itself. In this case, I have two equations. Equation 1 has much more potential for getting either the x or the y by itself more easily than equation 2. So I would probably solve equation 1 for one of the variables. So using equation 1, I decided to solve for x. We could just have easily solved for y, but I chose to solve for x by subtracting y from both sides to get x equals 1 minus y. I then take my 1 minus y and substitute that for equation 2, for the x in equation 2. We then have to distribute. So I have to distribute 2 to the 1 and 2 to the negative y. So 2 times 1 is 2, 2 times the negative y is negative 2, minus the 3y equals 12. Combine the like terms here, so you have 2 minus 5y equals 12. Subtract 2 from both sides to get negative 5y equals 10. Divide both sides by negative 5 to get y equals negative 2. We know what y equals, now we have to find x. So I chose to use my first equation and put the negative 2 in for y. So x plus a negative 2, or x minus 2, equals 1. Add 2 to both sides to get x equals 3. We then check. Again, I chose to use the first equation, 3 plus a negative 2 equals 1, 1 equals 1, so it checks. Let's take a look at another example. Again, when I do this, I like to look for the equation that has the letter that's already by itself. Notice in equation 2, both of the letters have a number attached to them. In equation 1, the y has a number attached to it, so I would probably go ahead and solve for x. So to do that, I subtract the 2y from both sides, so I get x equals negative 2y minus 5. I take the negative 2y minus 5, that's going in for x in my second equation. We have to distribute. So we have negative 8y minus 20 minus 3y equals 2. Combine your like terms to get negative 11y minus 20 equals 2. Add 20 to both sides to get negative 11y equals 22. Divide both sides by a negative 11, and I have my answer for y is a negative 2. I went and chose to use equation 1, and I chose to put the negative 2 in for y. X plus 2 times negative 2 equals negative 5. Multiply to get x minus 4 equals negative 5. Add 4 to both sides, and we end up with x equals a negative 1. Checked it using the second equation. 4 times a negative 1 minus 3 times a negative 2, and we're checking to see does that equal 2. So negative 4 plus 6 equals 2, 2 equals 2, so it checks. In this one, we have 6x plus 5 equals 8, x plus 3y equals a negative 7. Again, looking at the equations, the second one has this x that's already by itself. So therefore, we would go ahead and subtract 3y, so we end up with x minus 7 minus 3y. We take this and we substitute it in for the x in the second equation. So we have 6y plus 5 times negative 7 minus 3y equals 8. We end up distributing and combining like terms to get negative 9y minus 35 equals 8. Add the 35 to both sides to get negative 9y equals 43. Dividing both sides by that negative 9, notice this time we don't get a whole number for an answer. We have to use an approximation here, and sometimes that happens when you solve systems. They don't always come out with a whole number. So we take our approximation for y and we substitute that in, and we end up with an approximation for x as well. X equals a negative 7.34. Your homework assignment for this part is on page 371, numbers 17 to 22.